All right. Well, this is what I'm here to talk to you about. I've spent the last terminal number of years working on data privacy protection, security in Office 365, and encryption has consumed 3 years of my life. Just recently, actually, the last time I was in Orlando was in 1990, and I was in boot camp in the US Navy, and my specialty after that was cryptography and encryption devices. So I've been doing this for 27 years. And I'm still waking up in the morning and getting excited about it. But the part that's exciting now is that it's gone from military application, of course, to every consumer and child on the planet that has any kind of, information that they want to digitally save or transmit. And largely what I spend my time doing when I'm not working with my great colleagues on the engineering part of features is talking to CISOs and their reports and CIOs and sometimes COOs about the mythology about encryption in the cloud. And it's not a ton of it, but it's pervasive and it's really, unfortunately, insidious. And I'm not here to talk to you about Microsoft technologies, although I work for Microsoft. This is not a session about any Microsoft technology. This is a universal truth session about encryption dynamics if you're using cloud services. And I'm going to focus on software as a service, but I'll talk a little bit about why that's different than platform and infrastructure and other things. So it's impossible to have this session without going over some basics. And I beg your patience. I believe I know what I'm doing, and I've had this discussion hundreds and hundreds and hundreds of times to know what the flow has to go, how it has to go. And actually anybody in here a cryptographer? No cryptographers. Anybody in here who owns cryptographic systems? Okay, a few people. You're the ones that are most at risk of misunderstanding probably encryption in the cloud. And I fell into that trap myself because I worked at Microsoft a long, long time ago on the systems that we issue certificates and keys with. And so I had a long history that led me to some of those same false conclusions. So it's critical to go over the basics actually of data encryption to remind people of what they think they know, and hopefully a little bit of humor along the way. So that'll lead to realities of encryption and cloud services. I'll focus on the two major myths of cloud encryption. And then hopefully I'll lead time for Q&A. This was supposed to be a 75-minute session. It's a 45-minute session. So I've had to defrag as much as possible and have to have at least one question for me so that somebody can take home this wine and I don't have to take it back to Seattle with me. So anyone? I heard it. Where? All right, thank you. Yoda, the master of all cloud encryption wisdom right here. So what do you have to unlearn? Well, the building blocks of encryption, I think, now my wife wouldn't understand this. My children wouldn't understand this necessarily, but anybody in technology probably knows. The very basics are you've got data, you have some kind of key, and you have math. And that's what creates encryption, right? But we've lost sight, I think, of what it actually is. That's how it's composed, but what is it? Well, I like public sources because they're easy for you all to look up and verify. So I like Wikipedia a lot, and this is the Wikipedia definition. I think it works really well. And I focus on this word access. And if I give you a file and it's encrypted, and then I unencrypt it and I give it to you, you now have access to that file. You can read it, you can view it, you could process it further, you could compute against it, which would be something like search, for example. And to do that, you have to be able to at least use a key. You don't necessarily have to have the key, but you have to use a key to unencrypt the file. So encryption is encoded data that if you can access it, all of these things must be true. If you disagree with any of that, then feel free to heckle me there. I don't think there's anything controversial about it. Something else that people working in I think, in cryptography or cryptographic operations kind of might lose sight of, and especially people that are not in that area, is where it happens matters tremendously. So you hear this Apple story last year, and you might hear, someone in your division, department, company talking about cloud encryption, and those can be two very different things. Using WhatsApp or using a message app on your phone that provides encryption is different than a lot of what happens in the cloud. So here's a simple example. I like to think that mobsters would use encryption if they could all the time. So here's one telling another one, did you do away with this guy? And so he sends this message back saying, yeah, the shoes fit well, he's a goner. And that goes over to, and you see this dotted rectangle is the entire scope of the encryption, right? So it encompassed everything in the system from beginning to end, and this is what a lot of people refer to as end-to-end encryption. So that same example where those same two people want to transmit this, but they're not using WhatsApp or what have you. They're using an unencrypted endpoint, but they want to send it over an encrypted channel. So here it leaves the device, goes to a cell tower, enters some facility, probably through wires, and then that facility has an encryption device, and they encrypt the data and send it potentially anywhere over any medium. So obviously in this case, law enforcement could use their systems in America, I'm sure there are systems abroad, in cell towers to intercept, as well as in the facility. So if law enforcement came along and provided a legal order to one of those entities, they could probably get the transmission. So where the encryption happens matters tremendously, and that often gets overlooked, and that is very important in SaaS. Okay, so another fundamental. All right. Again, when was maybe the first time somebody yell out, first time you heard SaaS? What year? 2000? Head nods. Maybe later than that, 2003, 2004, 2005, something like that, right? So we've been thinking about this for a long time, and the term software as a service has kind of fallen by the wayside. We just say SaaS. And what is that thing? Well, I just said it, so that's no surprise. It's software as a service. But what is software as a service? Anyone? It's a really simple answer. What is it? Okay, that's one way of thinking about it, but it's software, right? That's what it is. Software as a service is just software served up some way that might be different than sitting on your local PC, but it's just software. So what is software? It's a question probably most of us haven't asked ourselves for a really, really long time. Well, it's an application, right? And that's a term, if you go back to when I was young, that was kind of new then, but it's fallen by the wayside. Now we use the term app, or we say app, we don't even say application, right? But what is an application? What's the definition of an application? Well, you can go look this up again. It's software that processes data for the user. So if you take that SaaS acronym and you were to kind of expand it with this definition, you'd say software that processes data for the user as a service. So SaaS processes data. If it's not processing data, it's really not SaaS. IaaS, PaaS, right? IaaS isn't processing your data. It could be shooting it around the globe. It could be storing it somewhere. It could be just hosting the app itself that has the data inside it that's processing the data. But SaaS processes user data, okay? So we have these constructs, and as I said, the dynamics of encryption in the cloud are different for these. With software as a service, it processes user data. So if you have encrypted data in that SaaS service, it can't process it. I'll be happy to get into minutia details about sort of evolving encryption standards in cryptography for very rare use cases of processing encrypted data, but that's not what we're talking about here. We're talking about mainstream encryption and uses of user data. Platform as a service may or may not. An example of that might be a database application as a service, and in those cases you might have some data that's exposed to the cloud service provider. It's not encrypted, and you might choose to have other data inside of it that is encrypted and the cloud service provider cannot process. They can store it and send it back to you, but they can't process it. And infrastructure as a service just doesn't process user data. So, you can put encrypted blobs into IaaS and have yourself managing the contents inside the encrypted blobs, but the IaaS provider is not exposed to that data. So pretty simple stuff. One of my goals in developing this view of encryption in the cloud is that you can share this with an attorney. You can share this with a CISO who doesn't have any encryption background, and they can read these slides maybe on their own or with a little bit of guidance from someone that understands this a little bit better than they do, and it's going to be perfectly understandable to them. Some gotcha terms that I've been trying to fight for the last year or two. This one is really bothersome. But also hold your own key and control your own key, which is really a kind of a riff on the theme of hold your own key. That pretty much mean the same thing. And one way I've tried to convince people, there's no meaning for these terms. There's no actual accepted definition. Like if I said to somebody who works in cryptography, AES, the Advanced Encryption Standard, we would both know exactly what I'm talking about. There's no ambiguity there. You might ask me things, like what mode are you running it in, but we know exactly what we're talking about. If I said an X509 certificate, or if I said a kind of a smart card certificate, we would all know what we're talking about. If I say BYOK, okay, so what is it? We look it up. You get bring your own knife, bring your own kegger, bring your own keyboard, and you do get bring your own key, but in parentheses you see it says it has Microsoft after it. So that tells you that this is a very specific term, maybe that it's finding on a search of just that. So it's not saying Google and Amazon and Microsoft and Facebook and anyone else all think this is the same thing, right? It's not. It's always different, in fact. Even within Microsoft, we have multiple teams using this term in the public for which the definition is different. So if you see these three BYOK, HYOK, CYOK, any of the YOK terms, you don't have to read this right now, but I give you the slide deck. You can respond to those people and say, I don't think that really has any meaning. Let's talk about what the business problem is. So what are business problems? They're not who has my key. That's not a business problem, that's a technical issue, that's a technical implementation detail. Business problems are things like I've got to adhere to regulations, I have to make sure that auditing covers all of my controls, I have to know when my data is accessed and who accessed it. Those are perfectly valid business problems. And even I must ensure my data is encrypted because a regulator might say, or PCI, for example, says this data has to be encrypted. It doesn't say where it has to be encrypted necessarily, or I should say what the key structure looks like, or who has access to the keys, but it might specify encryption. But none of these things are, I have to own my own keys, I have to control my own keys, I have to bring my own key. And I'll talk about industry regulations, and I have resource links in the back of the deck that specifically give you links to those industry regulations. So the number one rule for encryption, if you're talking to a business decision maker, technical decision maker, is we have to define the business problem first. Jumping to an encryption implementation is putting the cart before the horse. First, we need to know what it is we have to accomplish for the business, and then we can decide if encryption has anything to do with the technical architecture. Business problem first, technical solution second. So what are the main myths? This is the primary one. And I'll drive this home really well, I think, with the public documentation published by standards organizations and by vendors. That if I own or control my own key for SaaS, that I'm safe from a government demand of data to that cloud service provider. So why is this a myth? Anyone? Okay. Okay, we go back to earlier in my material. If you're using SaaS, then the SaaS service provider has to be able to process the data. That's the definition of SaaS, is they have to be able to process the data, which means the SaaS provider has to have the data in unencrypted form. It might enter their cloud in an encrypted form. It could be encrypted in transit. It could even be encrypted like with RMS or something of that nature, or an S-MIME certificate. But if you want them to process it, then they have to share key material with you in order so they can unencrypt it and process it. Otherwise, they're not able to provide SaaS services. So what's implied in that statement is that SaaS can work without processing the data. And we know that that's false, that SaaS can't work that way. So it violates the fundamental definition and model of SaaS. So that is a myth. If you have a key and you give it, or you give your data to Microsoft, Google, Amazon, and your data is encrypted, you can put it in their SaaS service. This is not specific to any cloud vendor. You'll just get storage and transmission. If you think about the old, like when we were all in probably high school, I don't see any really young people here. So when I was in high school, one of the first things they taught you in computers was, here's like the CPU, and this is a keyboard, and here's a screen, and here's a disk drive, a floppy drive, right? And they would explain to you that the CPU is the processing unit. That's why it's called a central processing unit. And the disk is the storage thing. And the keyboard and the screen, before we had the internet, those are the input-output devices, right? So you have those three things. You have input, output, you have storage, and you have compute. And SaaS is the computer. It's the CPU. So if it's not processing, it's not really acting as the CPU. That's what you're outsourcing, in effect, with a SaaS application. That's why this is a flawed statement. Okay, myth number 2 is that I have a regulatory, in particular, a regulatory requirement for a key management model. Sole control is actually, that's quoted in one of the regulations that I'll show you later. So this is a myth almost universally. And that's why I say the regulatory mandates are very, very rare. I'll go over where I know that there are mandates that are different than that. But the second thing is, if you're in a regulated industry, then you know that your regulators, really their job is supposed to be to reduce the risk of the organization. So if you're regulating banks, then you want to try and reduce the risk that the bank is going to have like a financial loss. And obviously, if a bank gets compromised and their encryption keys get compromised, like in the case of a cloud-scale ransomware attack, for example, that's really bad. That's a high-risk scenario. So if you're a regulator, you wouldn't want that to happen. And it wouldn't make sense for you to then tell the bank, hey, don't do something that's going to reduce your risk. And owning your own keys can be a larger risk than not owning your own keys, because you might either A, do a worse job potentially than a cloud service provider would do protecting them, but also best practices in the enterprise world before cloud were that you distribute keys. So I'll give you a real world example. At Microsoft, for what you'd call root keys, like code signing keys for Windows and keys that we use to issue identities in the company, those are rooted in hardware security modules, a hardware device, and the card sets that are used to administer those are distributed so that our legal department has a set, our IT department has a set, and there's a third set that's owned by another part of the security part of the company that are held offsite in like a bank vault. So no single organization could lose all of the keys or could have them stolen, by a rogue employee or a thief, an actual. We've had people actually break into Microsoft facilities, so like corporate offices, not our data centers. And so in the cloud, we need to rethink best practices and think, is there a way that I can use cloud in the cloud world to extend the best practices of the kind of the non-cloud world that I've had before? And I don't think those best practices have been developed yet. And in fact, I'm going to show you some of the Cloud Security Alliance recommendations. I think they're a good example of an organization that should be promulgating cloud-friendly best practice updates, and they haven't yet done that. And I've been talking with them. I talked with Jim Rivas, their CEO, back in June. I met with him and their staff, and then I presented the Bright Talk series is hosted by the Cloud Security Alliance. And tonight I'll fly back to Seattle, and tomorrow I'll speak at a Cloud Security Alliance conference. And they've been very gracious in letting me stand up there and say, the Cloud Security Alliance is not doing their job publishing the recommendations on encryption in the cloud right now, and I'm trying to work with them to help them move that along. But the cases that I'll mention are Israel. They have a central bank that's sort of like the central bank in the US, but has a stronger regulatory role. And I have a link in the resources to their document that actually specifies the encryption key management that they mandate for the banks in Israel. And the US Department of Defense has a regulation for using cloud services. So it's not about their on-prem stuff. It's if you outsource to a cloud service, there's a certain encryption key management model that you have to use. And the third one is New Zealand, the government of New Zealand. And again, there's a link in the back, and you can go read that. And I've been talking with the government of New Zealand about their policy and how it's working against. In fact, both Israel and New Zealand have admitted that their policies are working against the commercial entities in their countries because they deny them the ability to take advantage of using, it's not a Microsoft thing, just any cloud service for a lot of business purposes, for most business purposes. So this is largely a myth. If you're in a bank in Israel, then this isn't a myth. It's just an unfortunate regulator misinterpretation or misunderstanding of cloud security and cloud encryption and what you can and can't do with encryption in the cloud. And if you're in New Zealand, I know the team, Microsoft has a good presence there. They're working on trying to get the government of New Zealand to come around and just at least admit the dynamics that I'm talking about today, and then potentially go back through the legislative body and change the law. So how did this happen, though? Particularly that first myth of if you own your own key, then you're safe in SaaS. Well, let me show you some examples. And no disrespect meant to any journalists, maybe that are here, the ones that published these articles. I don't expect a journalist to understand encryption, just like I don't expect a lawyer to understand encryption. And I'm married to a lawyer, and I have a child who's a lawyer, so no disrespect to lawyers either. So this is an article from Slate. It's a few years old. All this stuff is within the last, say, 3 years, which, that carries the inertia into today, right? This kind of stuff doesn't just happen overnight. These articles happened in 2013, 2014, 2015, and then they work their way through like word of mouth and compliance departments and non-questioning individuals. And now here we are in 2017, and you see kind of an upswell of mandates that don't make sense because they defy the laws of SaaS. But you can see that in this Slate article, the writer says, enterprise customers who prize security might be thrilled to hold their own encryption keys. Now, there's no explanation in this article of that sentence. Why would they be thrilled to hold their own encryption keys? What does it actually do for them? That's not stated in here. I would argue it's because the author didn't know. They were probably hearing this from someone else. They might have been hearing it from a marketing person at a cloud, vendor of some kind who just said this, and they said, yeah, sounds reasonable, so I'll put that in my article. I don't know, but this statement on its face is left there for you to be influenced by, but it doesn't. There's no, how can you question? You need to go and question this. Why would I be thrilled to do this? And then they're talking to Aaron Levy, who was the CEO of Box, still is today as far as I know, and he says, we are exploring ways that in the future our customer would be responsible for its keys. Now that's what he said. Just leave it there. He doesn't say anything about what that's going to do, just that they're exploring the possibility that customers could participate in the key management of the Box data that they have in the service. So that's Slate. So then we go to, this is a TechTarget article, and I've highlighted here, since the customer keys are no longer kept with Box, it prevents the vendor from exposing any customer keys in a potential data breach or turning them over to government. Again, could be convincing to the casual reader, but what it doesn't say is that the data of the customer is not being turned over to the government. It says that the keys are not being turned over to the government. Now that's critical, okay? And when I said that where encryption happens is really important, that is highlighted implicitly in this statement, okay? And I'll show you the Box solution and why this statement doesn't really mean anything and why that is, okay? And then a very strong statement here on this bottom highlight I put in, if government agencies such as the FBI want to obtain the customer data stored by Box, they have to go through the customer, and they can't get it through Box. Okay? Leave that, just let that sit for a minute, and then I'll show you what Box says. This is an article a journalist wrote. This is not Box, right? I'll show you what Box says about this. Okay, so here's Box. This is straight from their website. All the URLs of all of these pages that I'm showing you are either in the notes or they're directly on the page. So this one, you can see it's in the page, probably be in the notes too. So this is their KeySafe model, which is an integration with Amazon KMS. And so the customer holds keys in Amazon and can do it in a couple different ways. But if you notice, step one, the file is uploaded. Okay. Step two, the file is encrypted. So where matters. The file was not encrypted as it came into Box. If Box has the file in unencrypted form as it receives it, what is possible with that file? Use your imagination. I don't have to tell you, okay? You can imagine, I'm sure, all kinds of different things that are possible there. In addition to that, what's not shown on this is that if Box wants to create a search index, that it needs, even if it encrypted the data and it wanted to later update the search index, it would need to unencrypt the data itself in order to add the data to the search index. And it doesn't talk about what the search index is, how the search index is being handled either here. So I don't see this as a malicious marketing slide, but it leaves a lot to the reader to try and figure out what might be going on and what's possible. So down at the bottom, you see the link to the terms of service for Box. So that statement about the FBI, the NSA can't get the stuff from Box, they have to go to the customer. What do the Box terms of service say? I pulled this morning, by the way. This is very, very current terms of service. Okay. You agree to provide Box the right to transmit, process, use, and disclose content, and content is defined in the first paragraph. And it says only, and then there's 3 clauses. And the third one says, as otherwise required by law, regulation, or order. Okay? Box doesn't say in their terms of service, we cannot possibly give your data based to a legal order, right? To an entity that brings us a legal order, because as that journalist said, it's impossible. Box is not going to make that claim. You can figure out why that is. Okay. So on to the Cloud Security Alliance. I really like their documentation. I mean, don't get me wrong. it's, what, 130 pages, I think, in their recent V3 of their cloud security recommendations. There's a lot of good stuff in there. And I'm just pointing out that their encryption content is either wrong, lacking, or mainly it's lacking. It leaves the reader to try and tease out what exactly they're saying. But the most important part to me is actually the beginning of the encryption section. And the reason is this one word. I mean, you know, everybody in here I'm sure can read, probably all of us can read English. And it's this one word. So they don't, what do they say here? They say, if you as a company didn't sign a good contract, or don't know the history of the company you're working with, or didn't audit, no. They say, if you don't trust, that's what they say. If you don't trust the organization that stores your data, what does that mean? Do you trust me right now? I don't see anybody shaking their head yes. So you don't have to trust me because you don't sign a contract with me. You sign a contract with Microsoft if you're going to let me be part of the team that runs the service that provides you with SaaS, because I'm on the Office 365 team. So what does trust mean? Well, let's look it up. Okay, it's on the right-hand side. Let me blow that up for you, okay? Let's blow that up. One party is willing to rely on the actions of another party. The situation is in the future, and the person who's trusting abandons control over the actions performed by the trustee. And as a consequence, if I'm the truster, I'm uncertain about the outcome. So this describes, for example, I had my 17-year-old daughter drive me to the airport earlier in the week so I could get over here. And she had to get up at like 5:30 in the morning. She's a high school teenager. So admittedly, I didn't just trust her. I actually made sure that she would get up in the morning. But let's say it wasn't her, it was my brother-in-law who lives a couple miles away. And I said, you'll take me to the airport, right? You'll be at my house at 5:30 in the morning. Am I gonna have him sign a contract? I trust him, right? Because he's my brother-in-law. You know, we're family for a couple decades, and you know, we have a track record. And he has a track record of picking me up when he says he's gonna pick me up, even if it's 3 o'clock in the morning, right? So I trust him. So I don't have him sign a contract. I don't audit his phone, you know, alarm is set, right? I don't do auditing. I'm not asking him for logs, you know. Trust doesn't have really anything to do with commerce. This is about like human relationships where those things don't exist. So why CSA says trust, why they would say if you don't trust that you need to encrypt the data before it goes into the cloud, I pointed that out to them. That is just a bald-faced wrong statement. That starts the whole chapter off on the wrong foot. So how does trust work in commerce? Well, it's pretty simple. You sign a contract with me, or with Microsoft, Google, Amazon, Box, and that contract is enforceable at law as a binding legal agreement. Okay, pretty straightforward. That's how trust really exists in business, is a contract, not the word trust. You don't need to trust Microsoft. You need to make sure Microsoft has a good contract, okay? It's great if you trust me and the rest of my colleagues at Microsoft. I hope you do. I think you should. I think we've given people good reason to, but I'm not gonna ask you to just send me your data because of that, right? So, contract, okay? And I put this together. This is just my view of the world. Someone else may rejigger these or change, decide there's something else there. But I said contracts at the very bottom, and then there's what can I audit and what are the stated capabilities of the cloud service provider. And the audit should determine those capabilities and the warranties or the representations. And then what's their motivation? What drives the business of the cloud service provider, and how does that relate to whether I think they'll secure my data according to their contract, according to their promises? And then there's some things that I think matter, like the public statements that a company makes. I put these in, I think, order of importance at the bottom moving up. And trust is that ineffable thing. In fact, if you didn't notice, in the definition on the internet, it's listed as an emotion. Trust was, if you didn't notice the label next to it, it said it's an emotion. So that emotion comes from these, underlying foundational things. So technology follows contract. In fact, as someone who's dealt with lawyers at Microsoft, wonderful people, amazing lawyers at Microsoft, been dealing with them for years, they effectively tell us what to do. I mean, we can tell them what we're capable of, but they can tell us, you can't do that, that would violate the law. So law first, technology second. So just segue back to, this is the Cloud Security Alliance. Again, I had to kind of leap off there on the trust definition, but back to that. This is down deeper in their domain for encryption, and they point out, whenever possible, avoid any reliance on cloud providers to protect and appropriately use the keys that protect your critical information. So it's pretty clear that they're giving, this is one of the key standards bodies, at least in the United States, that is promulgating a recommendation which doesn't make sense in SaaS. This might make sense if they said, if you're using IaaS or if you're using PaaS and you want to protect some or all of the data in that service, then do this. But this statement on its face doesn't make sense for SaaS unless you interpret it as don't use SaaS, kind of the way that Israel has, okay? Secondly, this goes back to that myth number one, right? If I have the keys, then I'm safe. So they specifically say, if only you have the keys, only you can access your files. Not really helpful if I want to use a SaaS vendor, right? And then lastly, something again I wanted to point out is their use of the word best practice. So best practice key management practices. They say best practices from a credible source. Now that's interesting because I would argue that the Cloud Security Alliance would say they are one of the most credible sources of recommendations and best practices. So they're being self-referential here. They're saying use credible best practices, and these are the best practices that we're telling you to use. So if this is what you're left with, then you're kind of stuck if you're trying to use SaaS and you want to tell your attorneys or your compliance department is saying, we can't expose any of our data to that SaaS cloud service provider. We want zero risk. Well, then you can't use the SaaS. You can't use any SaaS cloud provider at that point. Okay. And again, I'll talk with, in fact, Jim, the CEO of CSA, is going to be at the conference tomorrow that I'll be speaking at, and I'll talk to them about the fact that best practices need to evolve to include this new paradigm, and they really haven't evolved. And I would argue that best practices for key escrow should include using the cloud. So maybe that means if you're using a Microsoft cloud, that you escrow keys in the Amazon cloud, or vice versa. Use the benefits of cloud where you take an encrypted blob of a key and stick it in Amazon, and that key's only useful in Microsoft, so Amazon can't do anything with it. That could be an updated best practice for key management that doesn't exist today. And back to the myth number one, it is highly recommended that organizations maintain their own keys. And then they kind of give themselves a little out or use a trusted cryptographic service provider from a source that currently maintains such a service, which I would argue Amazon has, and so does Microsoft. Amazon has several flavors of key management capabilities in their cloud service, and Microsoft has Azure Key Vault. And both are, I think, very trusted, rightfully so, cloud service providers. So seems like there's a little wiggle room, but it defies some of what they've said earlier. So again, I'll be working with them to try and get this cleaned up. So what have we learned in most of the time I had here? Software as a service, processes, user, data. Full stop. If you want to not have the cloud service provider have your data exposed, then don't use SaaS, okay? Build it on-prem, maybe a private SaaS cloud could be a potential route for you. Contracts determine SaaS privacy. Now, arguably, contracts, they actually define privacy no matter what you're using, but in SaaS, that's what you have to rely on. With IaaS, they might not guarantee privacy, but you could build your system to use the IaaS service so that you get it anyways. With SaaS, that isn't the case. If you're going to use SaaS, you need the contractual guarantees of the SaaS service provider. I tried to tone this down. I don't want to tell people, stop reading eWeek, don't read CIO magazine. There's a lot of garbage out there. But so I'm trying to kind of reformulate that as, don't get your, why do we have meteorologists, for example, that we turn to for the weather forecast? Why don't we just have the main guy or gal who's up there doing the news say, hey, it's going to rain today, 40% chance, right? Because they're not a meteorologist. They're not encryption experts. The people that are writing there's a few writers out there who actually are. If you're reading Bruce Schneier, by all means, he knows exactly what he's talking about. I would trust anything he says on cryptography. And there's a few other people that publish like that, but if you're reading mainstream media and it's talking about encryption, especially in cloud, you should go find your source someplace else, and probably from the source itself. So go to Google, go to Amazon. We all have good papers on encryption available for you. And if you don't like what you're reading there because you just don't think there's enough meat on the bone, then by all means, tell Microsoft that. We have good feedback channels now pretty universally to tell us thumbs down, thumbs up on something. And lastly, define your business problem. Don't talk about encryption until you've defined the business problem that you're trying to solve. Okay. So I mentioned the Bank of Israel, the government of New Zealand, the US DoD. There's an interesting paper for the really propeller head minded. It's kind of an academic paper on international cryptography regulation, which does apply because it talks about what's possible in certain places, like China has very specific cryptography requirements for Chinese entities. And then all these sessions have already happened, so you can see the recordings of them. I just put the links to the sessions, and there's a good number of sessions at the conference here that covered topics that were related or specific to this. And I have 1 minute left, I think, for questions. And my email address is on the title slide, so if you don't get to ask a question now, and I've got a jet to the Orlando airport and get back to Seattle, feel free to email me and tell me that I'm full of baloney. All right. You have to stand up, and you're already standing, and tell me which SaaS service provider does what I told you apply to?
All.
All right, who said that? All right, do you drink wine?
I do. Is it red?
It's a 2008 Rioja.
I can't take it.
All right.
But thank you.
All right. Who said Yoda then earlier?
He was sitting right here.
Oh, and he left. Okay. Anybody read my bio? No. All right. What service am I a veteran of then? Anybody read my bio? All right, I heard that. All right, you've got a question?
I do. So what is your take, especially with the SaaS and encryption, on some of the cloud access security brokers and their capabilities that they are selling on being able to address this problem?
So CAS and CASB don't change any of the rules here. Mm-hmm. If they're being used purely as a CASB device and not as a CEG, then it's not really relevant to encryption anyways. If they're being used as a CEG, then it's exactly the same rules that apply. So if you're encrypting data at a CEG at that border before it goes into SaaS, then you've no longer decided that you're going to use SaaS. You're using whatever the CEG or CASB vendor can provide, and that if you want to define that as SaaS, you could. I wouldn't define it as SaaS.
But you're still leveraging the actual application that's being offered by the SaaS, but you were encrypting it prior to it entering into the offering.
What I'm saying though is if you, for example, if you use a CEG and you encrypt an email before it goes into Exchange online, you're not getting SaaS out of Exchange Online at that point. You might be getting something like SaaS from the CEG provider, but you're not getting Office 365 SaaS. You're getting Office 365 as a storage provider and a routing, right, a mail routing provider. But you've decided that you don't want advanced threat protection, you don't want the ability to do e-discovery natively, you don't want the ability to
for
search.
For 365 specifically, yeah, I would agree with
Or
that.
any
Yeah.
SaaS service, it doesn't matter.
I would disagree with any SaaS service, but for 365, I do agree. So, thank
Okay.
you.
All right. One last question? Yes, sir.
So all this is good. I like what you're saying. How do you convince a set in stone security department who believe all of these myths and change their mindset? Because that's the battle I'm fighting every day is they won't touch it. Just won't touch it.
Well, this session will go public, I think, in like 30 days. I did the Bright Talk session in June, and it's public. I think we'll be releasing more video content for public consumption. When I say we, I mean me, probably over the next, say, 60 days. That will be more targeted at a CIO, CISO level. So instead of a 45 or a 60 minute, it might be 6 or 7 minutes long. And try and tease them to go from that one to maybe the next one to get to 18 minutes or something like that. And then if they're unconvinced, then you can email me and ask me to come, get on a conference call or fly to, I'd love to fly to Auckland, New Zealand, but you don't sound like you're from New Zealand, so.
No, nowhere near this time. Sorry.
All right, thank you all for coming.